Karle. I am an artist. I'm here visiting from San Francisco. Thank you for having me. My professional world centers around art, design, innovation, and invention. But really it's motivated by something that is much more personal. It's motivated by what it means to be human. Living in this body and going through this world and just trying to get through the human experience and all the difficulties and struggles that come with that. So my work starts with this personal experience and then expands to our shared experiences. I was born with a life-threatening birth defect called aplastic. You can see bandages on my head. I was missing skin on the top of my head. And there was many other cases of children that were born with this, but they all passed away because the regions were much larger. My parents were pharmacists and biochemists, and they vowed to take good care of me and that I wouldn't have to live in a bubble. But I grew up wanting to do things that other children were doing, like gymnastics and swimming, and I couldn't because I had this physical constraint. So I had to think about how do I have freedom in physical constraint? How do I find a way to feel like I can do the things I want to do, even though I'm limited by the body? I had a number of failed surgeries until I was a teenager, because of course I wanted to remove those constraints. And when I was a teenager, I went to the Mayo Clinic and saw an excellent doctor who did an experimental skin expansion surgery, and it worked. This life experience influenced me in many ways from when I was born, including my interest in healing and augmenting the body. I've always been fascinated by the body, and it's our way of knowing this world. I made this collection of drawings when I was 5 on dot matrix paper, and you can see the tape stains where my parents proudly displayed them. I quickly learned the value of sharing my work because I'd see people come over to our house and get so much joy and delight out of looking at these drawings. I was interested in how the body worked and interested in how to augment the natural abilities of humans. When I was 11, there was an invention contest. I looked around the world for things that would need improvement as a way to get inspiration. And being an 11-year-old, I talked on the phone all the time. It was before texting. We had these like big phones. And I wanted to do things with both hands, like paint my nails or make snacks. So I thought, this was an idea. What if I can shrink down a phone and put it into our ear, or where it is in here, make a really small tiny phone. And that's what I invented, and entered the contest with, and I won. It was called a no-hand phone, and it's what we now know as Bluetooth or hands-free phone. This award really gave me the confidence to believe in my ideas, even if they seem far-fetched to people. So I went on in my 20s to develop patents, service marks, and trademarks in enhancing the human body. But, excuse me. But to me, it was more than just about the body. It's about how we live through the body, how we use our body, and how we use these tools. Creating art and design is how I explore and express the body, mind, and human condition. My work is very personal, and it's a reflection of my personal journey. It's a way to share with others. It's a reflection of the shared experience of being human. And also, it's an opportunity for me to study what it means spiritually and emotionally to live in our bodies and go through this life experience. Are these videos playing? Yes? No? No? We'll have to stick it on. I'll keep going while we figure it out. To me, art and design are on a continuum. Let's just wait till the next one comes up. You can sit here, that'd be great. Art is more personal. To make sense of one's own journey and through their life experiences and reflect how they see and go through the world. And design is more global. It's a way to make devices and inventions to support others with their experience of the world. Of course, there's a lot of overlap. So I originally went to college to be a genetic engineer. And then I realized it was kind of all motivated by art. I was really excited to express myself by making forms about the body. So I eventually graduated with degrees in art and design and also philosophy. And after college, before I began working as a full-time artist, I worked as a designer in the fashion industry and also the automotive industry. And my special trait as a designer is that I understand immersive consciousness. So this immersive consciousness is the idea that the car that we're in, the outfit that we're wearing, the environment we're in, brings about a change in how we feel about ourselves. And this really requires listening to needs if you're doing this as a designer. So you need to listen to what the company's directive is, you need to listen to what the customer wants, and then envision a design that will transform the person behind that wheel or in that garment to feel that way that they want to feel. But a bigger task to me is to bring about a change from the inside, because this is a way of changing something from the outside, an external trigger, to make you feel different. But how do you start from the inside? And as an artist, I wanted to bring that out and show that in some way. And that's when I started making biofeedback art. This is the first piece in a series of different kinds of biofeedback artwork. Over a period of 8 hours, I'd meditate on a table, lay completely still while I was connected to a vintage analog video processor. The video processor would process video in real time. So whatever was going on the inside would be translated to a visual output. And to me, and speaking to people that saw the performance, yes, there was experimental video art output in the process, but really the impressive part is the performance of this, because it's a reminder that we all have this internal information going on all the time, and to stop and notice what it is, even when we're completely still. Something else that goes on the inside of our body that we don't usually see is our bones. And I've always been fascinated by bones. Who doesn't love dinosaurs? I made this urn when I was 16, and it was the first piece I showed at a major institution. It was in group exhibition at the National Gallery of Art in DC. At the time, this piece was very much about death and protection. And to many, bones represent death. But to me, they represent life as well. I had a renewed interest in bones when I got pregnant. Every day that I was pregnant, I was just inspired to think about how these two cells came together and formed all these exquisite structures. I was in constant awe and mystery of the amazingness of how this little life was formed. And this collaborative work was the greatest piece that I ever made. So after the baby, I went back to work as an artist, and now as an artist in residence at Autodesk since the beginning of the year. And my inspiration from the baby forming led me to create artwork about bones. I was thinking about how bones form and their generative and parametric qualities. Some were made from reality capture, and then applying generative patterns. And some were designed from scratch in CAD. Some were a combination of both reality capture and CAD design. And all of them were 3D printed because additive manufacturing is how bones are formed. And I felt like I was really making beautiful objects, and I was learning a lot about the technology, but it just felt like there was something more. I wanted to actually mimic how bones grow and form. I wanted to make things that looked like these exquisite specimens of bones, or antlers, shells. I was thinking about creating some kind of generative computer program that would surprise me and create something that was new but familiar. But it seemed like it fell short because I kept thinking, if I'm trying to replicate this intelligence, why am I making a computer program when we don't even really know how this works totally? I also had this feeling that even though I was creating beautiful forms, I wanted to do something that made a bigger impact on people and could reach more people than just sculptural work. So at the same time that I was being inspired by birth, I was also thinking about my dear friend from childhood, Lisa. Lisa is my son's godmother, and she has pulmonary hypertension, which is a terminal disease. She was up for a double lung transplant and was denied. She was ineligible her first time around because the medicines that are keeping her alive cause a scarring in her bone marrow. So I was thinking about Lisa and thinking, what if I could generate more bone for her, or what if I can actually just 3D print lungs for her out of her own genetic material? So that's when I thought, instead of trying to replicate bone growth and make sculptures about it, why not try to actually grow bone? Why not try to grow my artwork in bone? So instead of somehow trying to replicate this intelligence, why don't I work with it and learn from it? Let it surprise me, let it teach me. So the process I embarked on to grow bone involved leveraging stem cells to differentiate into bone cells. And this requires using or replicating the spongy part of bone, or the trabecular bone structure. This shape triggers stem cells to differentiate into bone cells. And I know that a lot of you here are very familiar with regenerative medicine, so you know that I had a lot of options of how to embark on this process. And I thought about a few things. I could take a cadaver bone and mill out the spongy part of bone, or hand carve it and strip it of its genetic material and start growing from there. Or I can 3D print a scaffold and grow something on that scaffold. I decided to do 3D printing. And the material I used to print the scaffold is a hydrogel. It's biodegradable and can be customized to include a wide variety of biological materials to encourage cell adhesion. The idea is that stem cells that are seeded onto this lattice will grow and proliferate into tissue and eventually mineralize into bone. At the same time, the scaffold will disintegrate. So what we're left with is bone tissue. And medically, the benefit is that somebody can donate their own stem cells to this process and make an implant out of their own genetic material, which would put them at a lower risk of rejection. But to get started, I needed a base design. So if this was to be used medically, we would design something that would be needed for a bone graft of a certain shape. But since I was making this as an art form, I thought, what am I going to make? What am I going to design? So I looked towards the real world. This is my friend Riley. I volunteer with Enable and Superhero Cyborgs, making children with limb differences 3D printed prosthetics. So here's a big inspiration. And I was also raised Catholic, and I go to these churches and I see these dead saints parts that really haunt me. I still don't totally get it. But it was a reminder of the life that was once there, shown in this form afterwards. They were usually bones. And I was thinking, how can I flip this script and somehow take something that's inanimate and bring it to life? So I came up with a hand design from natural bones and patterns inspired by anthropomorphism and osseointegration. And here's one of the first iterations. So from there, I had to get from this design to the lattice or scaffold that I can grow the stem cells on. I'm going to show you a very short video that describes my work. When I grow cells along form and design. So I embarked on this process of creating 3D printed scaffolds for cell growth. The design was inspired by real hand bones, and I looked at CT non-CT data as well as 3D scanning of bones. Process the complex data through Autodesk Unity. What's exciting about the software is I can take sculptural forms from the real world and now manipulate them digitally. I use Fusion 360, a 3D modeling environment, where I can sculpt and push and pull in a way that I've never been able to do before. I use a program called Interdisciplinary to process the design I create on a cellular level. It creates a trabecular structure throughout the design, which actually mimics the cellular structure of the spongy part of bone. Take that geometry and 3D print it on a cellular level using a number printer. It prints in microns, and I can control the exposure settings with precision. This is necessary for 3D printing with a custom-made high-def hydrogel medium that I use in the cell room. this project has been very challenging and exciting at the same time. And I think it's important to share my workflow. So I also shared it open source on instructables.com. You can, if you want to learn more, if you want to follow this, you can search Amy Karle 3D print scaffolds for cell culture, and it should come up. I feel it's important to share the learnings because this project was exceptionally challenging, and there was, every step was a really big hurdle to overcome. From processing the geometry that had over 500 million triangles in just one section, because that was what was required to mimic the cellular structure, to communicating between all the softwares and hardwares, trying to get them to process and read these huge files, and having to go in the back end of programs to create the slice files to send to the 3D printer. I mean, imagine trying to prepare these files, huge files for 3D printing. And then actually getting to the point where I could 3D print these in a biodegradable liquid that eventually turned to a gelatin. And all of the material testing that had to be done and new formulations that had to be developed with that process. Not to mention, that was all before experimenting with actual cells and refining the prints for all that they needed to go to grow and thrive. So this is actually the point that the project is at right now. We're currently experimenting with stem cells, and we've only done the first rounds of cell culture, and I'm looking for a biomedical or biotech partner who is interested in learning and advancing together on this work, and also some other work that I'm interested in pursuing, like pattern formation through strategic hormonal triggers. I leaned on a lot of experts and white papers, and this project was not easy. The thing that helped me out most was the people. I collaborated with bio-nanoscientist Chris Venter, material scientists Brian Enzima and John Varicella, and many of the software teams at Autodesk. And they really helped me in a way that I couldn't have done the project on my own. Institutions supported me in this work as well. The California Academy of Sciences, the Bone Room and Exploratorium were awesome, and they allowed me to study and scan their collection. And there was a lot of companies and people who generously stepped up to support the project in many ways, with supplies, materials, conceptual development, as well as my family and friends who supported me to make this work and helped out a lot. And since this is an interdisciplinary conference, I think it's important for me to share the value of what I've learned from working together. This, to me, was the biggest lesson in the whole project. A number of people asked me about my collaboration, and when companies would tour Autodesk that were from engineering companies or biomedical companies, the first thing they asked me was, how did you get everybody to talk together? How was it to work with scientists? And it was really interesting because as an artist in residence, I was not in a position of power where I could just hire a bunch of people to come out and help me. I had to, if I wanted to do something that was larger than I could do on my own, what I had to do was share my story and get people excited about what I was doing. And find people that had genuine interest and who would make the time and share the dedication and the passion to help me with this project. And that kind of takes a lot of courage. It's hard to step out of our own field and to do things, especially if we don't know if they're going to work or not. Working together provided a lot of value, speculative, conceptually, and also technically. Time-wise, too, I got to the point of the scaffolds in the bioreactor growing under 6 months, which was like kind of an unheard of time frame. And that was all possible because of all the talent that was supporting me on this project. I remember this day quite well with Chris. I had called a meeting with all the departments that helped me on my work. And I just wanted to get them all together because everybody was asking me questions about the software and different things. And the guys, the material scientists and the bio-nanoscientists stayed after for an hour. And I was so excited to see them drawing compounds on the board. And that day they developed my best batch of active formula yet. Also, that was the day that the stem cell culture began. And Chris and I when we were doing the stem cell culture, we're talking about the title for my piece. And we started talking about questions that scientists don't ask. And how we don't know how these cells totally work. Why sometimes cell culture works, why sometimes it doesn't. You know, usually an artist is in the studio alone, and we're alone with our own thoughts, and scientists are alone under the hood. And in this way, we were getting each other to think about these bigger questions that definitely inform our work. But technically, there was a lot of advancements that were made as well. Because I was an artist and I wanted to do something full size, I was actually just telling this story earlier today. I was like, this stuff's been done before, right guys? Like, we could do something human scale. And everybody was just looking at me like, well, okay, I guess, we'll try. So through this process, I found that this actually, and maybe you guys can correct me if I'm wrong, but we believe that this is the largest piece that's made for tissue culture yet. And with that came the development of a lot of new materials, because the materials would time out as we print over these long exposures. Usually scientists are experimenting, 1 millimeter, maybe 5 millimeters max. So to make a piece that was actually a human scale required a lot of developments and material formulations. Also, I wanted some to try to work with different colors too. So that also required us to make different formulations. Working with artists is really interesting because we tend to push a lot of limits and ask different questions and tell different stories in other disciplines. And for me too, working with other disciplines, the same is reflected back. As an artist, I think it's really exciting that I get to bring science and technology to a different audience with the work that I create, and bring these projects out of the lab so that more people can see them. Usually, in the lab research that I see, scientists are experimenting and maybe publish some white papers, but the general public doesn't see it, and they especially don't see it if it doesn't work. But as an artist, I can tell a bigger story, and then that raises awareness and interest, and that's sometimes more funding for the scientific research as well. But my work is not really to speak about the biology and technology as much as it is to combine the disciplines to help people think in a different scale. So this project to me introduces a few questions, big questions. First of all, what would be intelligent to design and create with living cells, both outside of the body and for the body? And then if we are implanting in the body and it's outside of medical purposes, how do we want to augment our bodies? We could create organs and replacement parts that a lot of us have been talking about, as well as new enhancements and organoids for our body that are unlike what we're naturally endowed with. And this is what now as an artist I'm trying to think of. And hand design for me isn't really the answer. I'm trying to think about what can make us beyond human, what can make us superhuman. I'm also thinking about the outside. What if I'm growing something else out of cells that wouldn't be implanted? Like what if our technology was made out of reprogrammable cells? And then it could grow into something different. And also, what does it mean for our body cells to live on outside the body? When we first started doing this experimentation, it was suggested that I use cancer cells because they're more robust, so we can just test the validity of these prints. If cancer cells can't live on them, then stem cells definitely can. And my initial response was definitely not, because I lost my mother to cancer. But she was a research scientist, and I grew up in the lab with her. When I do this work, I feel her very present with me. So I started thinking, what if I had her cells? And what if I was using her cells in this artwork? And even though she passed away, there was still a way of her body living on in some way. And I'm still wondering about that. So as we cascade into the next industrial revolution, where digital, physical, and biological systems emerge, we have the opportunity to become whoever we want to be. And when we think about wearable technology, additive manufacturing, bioprinting, neural networking, machine learning, mobile cloud supercomputing, let me keep going here, autonomous vehicles, robots that learn, genetic editing, the Internet of Things and people, I'm sure I can go on. But we could see the potential for a new renaissance when we look at all this stuff that we're working with now. If the 20th century was about physics, then the 21st century is about the biological. We have all this technology and we're in a place to realize an identity that's aspirational. To me, the most important thing to focus on is a value shift of who we want to become and really think through that. you know, this seems pretty obvious, but a lot of times with technological developments, we're in such a rush that we don't think this through. And it's especially important considering the rapid reproduction of self-generating systems and the cascade effect that our technologies are having. So we have to really pause along the way as we develop and grow and listen and evaluate and be flexible to making plans along the way. And we all have a role. This requires us to look at our paradigms and what we want to carry forward in our development as cultures and society. To me, the basis for successful workflows in the new industrial revolution is about collaborating with other people, company, technologies, and biology. When we step outside our currently established comfort zone and work with others, take risks and open our doors to collaborate, even if with our competition, we can quickly see the value of sharing and open innovation and the developments that can be made for the benefit of everyone involved. But it requires opening our hearts and our minds. And a lot of people haven't really gotten over that hump yet. So I ask you to start with you. I encourage you to follow your curiosity, even if it takes you to disciplines that you might not know much about. To have courage and faith in that vision, and to find out who else is interested. To collaborate to create something bigger than you could on your own. So right now, before we leave, I ask you to think about what's special in you that you offer, or what you're curious about. What would you pursue, even if you don't know the outcome of work it over? Now I know you guys are spread out, but I want you to find a partner that you don't know. I'm serious. I want you to tell them what you were just thinking about, what you have to share. I want you to listen to them. I'm going to make you guys do it. I want you to talk about if there's a way that you can collaborate, or if there's somebody you can hook them up with, or if you just have an idea like, hey, I saw this website that might interest you. Because this is the basis of interdisciplinary collaboration. So, and then after you guys are done, tell me about it too. I want to know, and I will be open for